Welcome back to the classroom. My name is Mr. Wong. Today we'll be going through the 2012 HSC Physics paper, question 27. We are covering Module 5, Inquiry question number 1 on projectile motion. So we have a toy bird that is launched at 60 degrees above the horizontal from a point 45 meters away. So you can see that's SX. And then we launch it at a height of 34 meters, such that the toy bird strikes the base of the wooden building at the top of the cliff. Okay, we want to find the magnitude of the launch velocity. We want to find this value here. So if we're looking into that, U needs to have the components of UX, and it also needs the component of UY. So these are the two equations I can use to find UX and UY. We don't have time, okay, and even we do know what these values are. We can substitute that in. We know what A is, but we have one issue. There's no way to sort of measure the UX and UI individually, at least not very conveniently. So what we're going to try and do is, we also know that UX is expressed as, in this case, U cos theta, which is cos 60. And we also know that UY can be expressed as U sine 60 degrees. So we're going to use these trigonometric sort of expressions to substitute into our equation. So that's where we're going to start. We're going to start with the horizontal component first. Reason being is that it's the most simple formula of the two to start with, and then we can go from there. Okay. So what we're going to do, Sx equals Uxt, we are going to substitute Ux equals to U cos 60 into this equation, and we're going to substitute our displacement in. So we get this formula or expression, 45 meters, U cos 60 t. Now I can move cos 60 over onto this side here. Okay, so it'll be 45 divided by cos 60. Let's see if we can get a round number from this. And we get 90. So it's 90 equals to U t. That's going to be our equation 1 that we can play around with later on. So I'll box this away. And then I'm going to use our formula here. So we know Sy equals to Uyt plus half At squared. We know that Y is 45. We're going to substitute the following formula in to this one here. Okay, now we can do our substitution in this question here. So the vertical displacement is 34. We can substitute Uy, so it's U sine 60. We can substitute in for t, so 90 over U plus half At squared, so half negative 9.8, and then t squared, which is 90 Ut. Okay, so what we can get here now is sine 90 sine 60, because U and U here cancel each other out. Just do a little kind of jot down there so we make that very clear. And then at the end of this calculation, we get negative 3,000 or 39,690 over U squared. So this is our new equation we get from that substitution. So now we're going to try and solve for everything. We're going to move this to the other side. We're going to move the 34 to this side here. So simply rearrange the formula around, and this is what we get as a general equation. So what we can do from there is, substitute everything around. Okay, so I'll simply flip my equation around and it'll look something like this. Okay, and then times both sides by this value up here or down here, and then square it. So it'll be u equals to the square root of 39690 divided by 96, or 90 sine 60 minus 34, and we get a value of about 30.05 approximate meters per a second. And that's how you do the question there. Obviously that's quite a lot of different steps. Creates a bit of creativity as well. If you found this video very helpful in explaining how to solve this past paper question, please give this video a like and subscribe if you haven't done so already, and I'll see you next time. Thank you for listening.